This video is the first video on calculus. Differentiation is a process of establishing the rate of change of the y-coordinate of a graph when the x-coordinate is changed. You are used to doing this for a straight line by finding the gradient. In this case, the rate of change stays the same no matter where you are on the graph, because if you think about a linear line, y equals mx plus c, the m, which is the gradient, is always the same value. But for nonlinear graphs, the rate of change is different at different values of x, as the steepness of a curve or a graph can often change. First of all, we're going to have a quick look at limits. So suppose we do not know the value of the function a, and if f of x gets closer and closer to a particular value, then x gets closer to a, and then it is said to have a limit. So we've just got two examples here to show you what that really means and how we can work this out using our calculator. So the first example, we're going to use your GDC to suggest a limit of 2x squared minus 8x all over x minus 4 as x tends to 4. So what x tends to 4 mean that as x is getting closer and closer to 4, what y value are we also getting closer and closer to? So what I'm going to do now is I'm going to go to the calculator and I will show you how we will do it on there. On our calculators, we're going to go to a graphing page, and in here we're going to enter our equation. So it is a fraction and it's 2x squared minus 8x all over x minus 4. And we just press enter. Here we have the graph. Now we want to know what's happening as x gets closer to 4. So to do this, we go to our menu and we're going to bring up the table and split screen the table. Now here we can see that our x values, we have starts -2, -1, 0, 1, 2, our x values. And we can see when x equals 4 here, it is undefined. There is no solution to that. And then we can see the solutions at 5, 6, 7, 8. Now, if we look here at our values, we can see they're going up in 2s, 2, 4, 6. 4 is only 5, then 5 is 10, 6 is 12, 7 is 14, which tends to suggest the y value, if it was possible, when x equals 4 would be 8. Now, it doesn't matter that it's undefined. We want to know what value is it approaching. So it appears here like it might be 8, but we need to have a bit more of a look into it. So what we're going to do is we're going to go to menu again, into table, and we're going to go to table settings. Now in here, we can choose where our table starts. I'm just going to put 3, because we want to look at when it's approaching 4. And I'm going to change the table step to 0.1. And what this will do is you'll see here it started at 3, but now the x values are going 3, 3.1, 3.2, 3.3, 3.4, etc. Once again, we can have a look, and now it's a bit closer to see what's happening. So at 3.9, it's 7.8, 4.1 is 8.2, so still suggesting that the limit would be at 8, because that's what it's getting close to, either side of the x equals 4. If you wanted to be a bit more certain, once again, we can go back into the edit, and this time, let's change it to 0.01, and we'll start the table at 3.9. So at 0.01, so we go 3.9, 3.91, and once again, if we look at our y values as we're getting the x value is getting closer to 4, it is still looking like the limit is going to be equal to 8, because from either side of this 4, as we go before it and after it, the y values are getting closer and closer to 8 as we approach the x equals 4. So we can say that the limit of this function as x tends towards 4, so as x gets closer towards 4, the limit would be 8, as that is the y value that it is approaching. Now we just said before that our limit was equal to 8. Then how we write this would be, we want the limit as x approaches 4 of 2x squared minus 8x over x minus 4, and then we just saw before that that equaled 8. Next example, suggest the limit of sine x over pi x over 180 as x tends towards 0. So this time we are doing our limit as x gets closer to 0 of sine x over pi x on 180. Now we'll just go to our calculator, do the exact same process we did before to find out what the limit is. So in our graph here, because we have sine and we are in AISL, we need to make sure that our angles are set to degrees for this to work. Now we want to input our function. So we want the sine of x all divided by pi x divided by 180. Now it looks like a straight line here. It's not a straight line, it is an actual sine wave, but because we're in degrees, one full cycle we need to be looking at a large value of 360 for our x value because of the degrees. So if you did want to see what the graph was to look like a bit better, we could change our zoom. And I'm just going to change the x to a maximum of 180. And you can see there now there's a bit of a curve happening as a sine function would, as we've looked at previously. But now we want the limit of this function as x tends towards 0. So once again, we're going to go into our table and look what's happening as x gets closer to 0. So at 0, you can see it's undefined. And if we look just before, we can see it's 0.999, getting bigger and bigger and bigger. At -1, it's 0.999949, and at 1, it's 0.99949. So we can see that this at 0, that will probably be the highest value because it starts going back down again after 0. Now, looking at this once again, we can see that more than likely it will be 1 that it's approaching. We want to be a bit more sure on that. We can change our steps. So here we'll start this at -1 and we'll change step to 0.1. So once again, you can see here that, yeah, looks like it's definitely getting closer and closer towards 1, as is the y value, as the x comes towards 0. So therefore, the limit of this function as x tends towards 0 is 1. And as we just found, the limit was equal to 1. And that is limits.